We are talking about inoculation to populate, or inoculation and population, depending on what part of this program you plug into. And we are walking through a gateway. We've talked about in the past where the root collar and some of these other tree preservation actions have opened up a gateway, and now we are to the point where we want to deal with insect and disease. We have one very major assumption that we want to base everything upon, and that is very simply this: must not forget it. Healthy trees don't get sick. When we inoculate to populate, we are enlisting the superpowers of nature. This is part of our natural strategy that we use to maintain plant health. If you have a healthy environment, you will not have insects and disease, and you don't have to spend the money. So much of what we do with inoculation and population is on a preventive basis to reinforce plant health so that they can use their own immunities to resist disease and insects. And if they use their own internal immunities to do this, you don't have to spend money. If you don't have to spend money, then it qualifies under our cheap to keep concept. Least cost, least risk for the most return of benefits. And we're going to be using a handful of these superpowers, which we will get into in a minute, but I'll go over them just briefly, and they are the super organization, the feedback loop, mimic, where we copy nature, the internal resource allocation, the IRA of the trees, and another ecosystem service that we're going to qualify as a superpower called nutrient cycling, and we've talked about that before. We'll get into it some more as we go through this session. There are 4 types of plant problems. There are insect disease, cultural, and environmental. And what we've seen in the first several root collar, aeration decompaction, topsoil, and biostimulant, where we've dealt with some of the cultural problems, the things that we do that interfere with this natural strategy that we're trying to implement for our trees and landscapes to be healthy. Those are cultural things, things that we do because everybody else is doing it, and it may or may not be the right thing to do. The environmental problems can be mitigated with irrigation and some of the things that we do with your designed ecosystem to control. And then the other 2 aspects of plant problems are insect and disease. And when we talk about this, in biostimulants, we referred to the first trophic layer, the living layer of protection in your landscape is a healthy population of insects. And I know that's going to confuse some people, but those insects are a part of a system that feeds other parts of your designed ecosystem, such as insects feed some of the birds, and then there are other organisms below the ground that feed upon one another, and their waste product in turn feeds the plant. And so there's a unique exchange going on, and this exchange is one of the superpowers that we want to mimic. We want to copy nature as closely as is possible. And so the layers of insect and disease prevention follow 3 categories, and that is very simply prevention, suppression, and eradication. And what we're going to talk about mainly is control, or this prevention aspect of it, and suppression, because complete eradication is in many instances not advisable, and we'll get into what we refer to as our integrated pest management concept right now in a minute. In order to control insects and disease, we have pesticides. Now the pesticides come in three categories. They are fungicides, herbicides that kill the weeds, and insecticides that kill insects. The fungicides, of course, kill dangerous fungus, but we have to be very careful with the use of all of these because our trees live in a fungal environment. And so a pesticide is any substance intended for preventing, repelling, destroying, or mitigating forms of life declared to be a pest. And so, once again, contractors, business owners, let's concentrate on what the owners want, what their concept of a problem is. Could be very different from what your concept of a problem is. And so their design intent, what they will tolerate, determines what we refer to as an action threshold. Now, an action threshold is the point at which an owner tells you that the damage or the nuisance created by an insect or a pest of any kind is intolerable. They can't stand it, or they don't want it, and there must be a change. And so an integrated pest management concept, an IPM, you'll hear me refer to it in both ways, is a way to manage pests that combines natural strategy into an appropriate preventive and control tactics using the cheap to keep tree protection actions as a single management strategy. To maximize efficiency, these tree protection actions should be used on a preventive basis. Now, we can be reactive, and when somebody calls you out to their Leland cypress and tells you that they're being eaten up with bagworms, or they call you out to their maple trees that they're being eaten up by leafhoppers and the leaves are going away, then you're going to have to take decisive, immediate action, and that usually involves a form of a chemical. Now we're back to inoculate to populate. All right, we're going to inoculate certain mixtures so that when they're applied to these trees that we can control eradication, control suppression, okay, your three categories of insects, and we're going to control them by suppressing their numbers, and if they're harmful enough, we're going to eradicate them from a particular species or an area of the designed ecosystem. And you have to talk about it like that because what's happening over here in one part of the designed ecosystem could very well be different from what's happening over here in the other part of the designed ecosystem because of microclimates. There are many different conditions which exist within a single designed ecosystem. You could have the Gobi Desert over here, and you could have the Okefenokee Swamp over here. And so you have to be able to be very flexible in the way you control, suppress, and eradicate insects. And healthy trees don't get sick, remember that. We must enable our trees and landscapes to resist insects and disease with their own immunity. And one of the ways we can enable them is to inoculate and populate beneficial organisms in the ground, and we're going to talk about that next. Now, in our previous session of biostimulants, we referred to microbes as being a standard part of our mixture here at the Fifth Element Protocol because we've done a lot of preparation to make sure that where we put these microbes, they can live. Now, microbes consist of mainly bacteria and fungus, mycorrhiza fungus that enable the roots to acquire external sources of water and nutrients. The bacteria can kill harmful pathogens in the soil. Trichoderma is the major category of that, but you also have protozoa, you've got algae, and various other amendments to these mixtures called metabolites that enable these microbes, these fungi and bacteria and things to live before they're applied, because you've got something living that comes off the shelf that has to be put into an environment where it begins to multiply. And here's where we inoculate to populate down below in the air down there. Remember, we prepared the surface. We've made sure that there's air and water and space for these microorganisms to live. And when we put these microbes in the soil, they have an incredible ability to multiply into millions and billions to benefit the below ground exchange of nutrients. We talked about nutrient cycling. That is the formation of nutrients in the soil so that when you put these elements into the ground, they are broken down and are passed from the soil into the tree in the necessary form that they need to absorb. It's the outside in instead of the inside out like it is with humans. It's just the opposite with us. And the superorganization, these millions and billions of creatures down below, will do more for your landscape than virtually any other aspect of it, because they are free. Once you put them in there and they begin to multiply and you give them organic matter, water, air, the big four, water, air, nutrients, and energy, when you provide that balance and you begin to measure these results, then you will see how important this nutrient cycling and the inoculation to populate really becomes, because it doesn't cost anything to create these conditions for fantastic reproduction. And so we can't miss out on this opportunity if we are to achieve cheap to keep status. Now, as a part of our inoculants, we've talked about and referred to in our previous segment of biostimulants as amplifiers. And these amplifiers, what we use to buffer the tank mixture, open up the pH window, and to increase the effectiveness of certain of the amendments that we put into our biostimulant mixture. Because inoculation and population amendments go into the biostimulant mixture. But we're dealing with these separate because I want you to understand that once you start dealing with the living part of a tree's ecosystem down below in the area below ground where you can't see, there's certain conditions that rule. Now, we had nutrient stewardship of the 4 R's, where we had right source, right rate, right time, and right place. And when you use your amplifiers, when you have the right balance of air and water, you don't have to use as much of these kinds of things as you need, which decreases the rate. The source is right, the rate comes down, and the time and place will be dealt with more in detail in our next segment of time, place, and space. But right now, you just need to understand that nutrient stewardship of right source, rate, time, and place can be adapted to the insect and disease control aspects that we're going to introduce you to in this segment of inoculation and population. So pay attention.